Very good day, Doctor. So, we are from Group 4, Section 3, going to present on our IPC project. So, in this group, we are consist of 5 members, which is Muhammad Aizil Fikri Roslan, Muhammad Ashraf bin Rosli, Muhammad Walidin bin Ahmad Shukri, Tanisha Sitananda, which is me, and also Yap Yong Yang. So, we are going to present on the given project. Basically, this project is about operation of fluid storage tank. In this fluid storage tank, we have several components such as start button. We have two relays that consist of C1 and C2. Next is two valves, which is S1 and S2. Two timers, which is one is for 120 seconds and 90 seconds, and followed by float switch. So the detailed explanation regarding the operation will be explained by my teammate in his next presentation.
Antonio, the E1909. So now I'm going to explain about the PLC diamond deputy designer for the system. So this one is a diamond deputy designer. So as we can see that there is a three symbols producer inside, which is the switches, relay, and designer. So the shorthand is represented as different functions. So for example, for the X1 switches, represented as a stop button. This one is a C1. With the dash inside is represented as the microprocessor switch. And this one with the curve is valve S1 represented as the relay. So this one is the result that you're going to observe. So these two is a timer. This one is the first switch, C1, and this one is represented as a C2. So now I'm going to start our experiments. So when I force through the X1, which is I switch on the stop button. So as we can see that the power flow is flow through the first line, which indicates that the power flow is ready for inside the S1 and activate the S1 already. So when the water is reaches a certain level, so it will activate the first switch. So which means that I force through the first switch. So you can see that the S1 valve is already deactivated. It's because the C1 relay is activated, so which will change the status of the C1 switches. So this one it will change from the normally closed to normally open. So it will change it to open circuit already. So in here, for the second line, as we can see that the timer 1 is already activated. So for the timer 1, we set as 120 seconds for the counting. So this one is a counter. Now it's counting around 40, 41, 42 already. So when it reaches the timer setting, you will just let the power flow through the following path, which the S2 will be activated. So now we just wait for the timer to count. Okay, so now the S2 valve is activated. Since the timer is already reached its setting, so you will just let the power flow and activate the S2. So at the same time, the timer 2 is also activated, which is you will also count until 90 seconds. Then we'll activate the C2 relay, which is this one is a S relay, which is indicated as a set relay. So when the set relay is activated, so it will change the conditions of this one, C2 switches, which will change from normally closed to normally open status. Okay, so now this one is a final result of the systems. So when the timer reaches 30 seconds, it activates the C2 already. So this one is like change the status of the C2 valve, C2 switches, so become open circuit already. So as we can see that this one, the S2 valve is deactivated already. So this one is a final result that we need to get. But in the end, we need to reset the C2 switches again. So hence we set another relay in the first line, which is this one is there's R inside the relay, which is indicated as the reset relay. So when the power flow through this relay, so this relay will reactivate the C2 switches, which will reset its conditions. So I will show you now. Since I forced through this switch, so the power flow is flowing back to the first line already. So when it go through the C2 relay, reset relay, so you can see that this one is growing in green already. So which is going back to the initial conditions already. So this one is the result that we meet the requirement already. So thank you.
Assalamualaikum and very good day. So my name is Muhammad Ashraf Berosli. CE190133 is my number metric. So I will present about the truth table for the PLC project. So we have two input here, which is assigned as the X1 and as the FS. So for the first one is X1. When X1 is 0 and C1 is 0, the S1 will become 0. And when X1 or 01, which is X1 0 and C1 is 1, the output also becomes 0. So when the if the X1 is in the 1, have the signal, and the C1 0, the output still 0. But if the X1 and C1 is 1, then the output turns to 1, like and get truth table. So for the FS, when the FS is 0 and C2 is 0, the S2 become 0, while the FS is 0 and C2 is 1, the S2 becomes 0. Same goes to when FS become 1 and C2 turns to 0, the output also comes 0. And when the FS and C2 in 1 condition, and then the output turns into 0 to 1. And for the when the circuit is built and the X1 and FS given, and when the X1 and FS is 0 and 0 for the FS, so the S1 and S2 output become 0 0. And when the output 0 1 input 0 1 for the X1 and FS, the S1 and S2 becomes 0 and S2 become 1. And when the X1 turns to 1 and FS turn back to 0, 1 0, which is the output will become S1 will be turned into 1 and S2 become 0. But when the X1 and FS together have an input 1 1, and then the S1 and S2 will have the input. So this is the truth table that our group gained for this project, and that's from me, and I will continue with my other friend to present. Thank you.
Hello, my name is Muhammad Aizil Fikri Raslan, DE 2041. So for this presentation, I would like to share the safety value of this design PLC programming for the system shown. So for the safety aspect, we can take the number 1, add emergency button, and then add warning and caution symbols. For the third, increase the number of relays, and then add fuse in the circuit. Last but not least, reduce human error. So for the first point, which is add emergency button, it helps to stop hazardous parts, which is loads. And then for the second point, which is add warning and caution symbols, it is because add a symbol to let know that the circuit is dangerous and can lead to electrical shocks. And for the point number 3, it is to avoid direct contact with the power supply. And for the fourth, add fuse in the circuit, so it prevent to break the circuit if has leakage current flow. And last but not least, reduce human error. It is because to avoid any incident caused by the employee. So that's all for me for the safety aspect for this design PLC programming. And then I will go through what you did for the economy aspects. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Waliuddin bin Ahmad Shukri. Now I'm going to present for the value economic aspect of process control for efficient and sustainable operation. So for the first point is to shut down the system automatically when are not in use. So the potential energy saving will reduce the percentage of electricity when the operation is turned off. Second point is to perform the maintenance or check the component each year or several months to ensure the components are in good condition. So the company will reduce the cost of usage to replace or repair the new components. Next point, for the point 3, is to reduce the processing interval time to increase efficiency in a short time. The the increased efficiency will produce good quality of output. So for the 4 point is to automatically process will produce good production and fluid flow that will save time of workers when they operate the system. So for the final point 5, reduce the number of workers to operate the system will save the labor cost because the process of some system are running automatically.